Okay, welcome all. Today we are going to see about the virtual lab. The experiment today we are going to see is 4:1 mux. So here in this D0, D1, D2, D3. This is what is the input for the mux, and the S1 and S0 is taken as the selection lines. So already in theory portion we have covered all these things. So let us go for the experiment. When you start your experiment, first see what all ICs we are going to use. So in this, for this circuit, we require 2 NOT gates and 4 AND gate, that is 3 input AND gate, and we require 3 OR gate. Okay, so we have taken the pin diagram for the reference. So here I have numbered this NOT gates. You can see we have 2 NOT gates. So in this IC, we are going to take 2 NOT gates. So I have used first NOT gate and second NOT gate. Okay. So 1 is given as the input, 2 is taken as the output, and 3 is given as the input for NOT, and the second NOT gate, 4 is taken as the output. Okay. And similarly, 3 input AND gate, we have to refer this pin diagram. So it is 7411. What I have done is these 2 AND gates I have used one IC, and the next 2 AND gates I have used one more IC. Okay. So first 2 AND gates I have taken the first AND gate and the second AND gate. Okay. So first AND gate is 13, 1 and 2 is going to be the input. So 13, 1, 2 is the input for the first AND gate, and 12 given. 12 is the output for the first AND gate. So 12 is taken as the output. Similarly, second AND gate, 3, 4, 5 is given as the input. So here we have number 3, 4, 5 as the input, and 6 is the output for this AND gate. So 6 is the output. Similarly, OR gates. Okay. So we have taken one IC for this diagram. So because we know it is 2 input OR gates, so 3 OR gates. So it is enough you take one IC. So we have numbered this 1, 2 input for the OR gate, and 3 is the output. This is your first OR gate. For second OR gate, we have taken 4 and 5 as the input. You can see this is your second OR gate. Okay, and this is the first OR gate which we have taken. Next, 5, 4 and 5 is taken as the input. So 4 and 5 is taken as the input for OR gate, and 6 is the output. So 6 is named as the output. And as usual, before we go for IC connection, all your 14th pin should be connected to VCC, and 7th pin should be grounded. Okay, that we have to remember. Okay, when you go for doing this experiment, when you go for checking the truth table, how you have to check this? You have to give your input 0, 0. That is S1 equal to 0, S0 equal to 0. So totally including this 4 inputs D0, D1, D2, D3 and S1, S0, we are going to connect 6 total. We are going to use 6 inputs. Okay, so 6 inputs in sense we have to take a 6 input switch. Okay. So see in Tinkercad, if 6 input switch is available, you can take. Otherwise, we can go for 4 input switch, 2 switches you can use. And but in Tinkercad, the 6 input switch is available. So let us go and take that one. Okay. So we know that mux means it is only, we know mux is nothing but mux will have only one output. Okay, so only one output. That is what is named as Y. So what we are going to do here is, how we have to check the output is, your output will be either D0 or D1 or D2 or D3. When you will get D naught is when your data D1 is available. That is D naught is available and S1 is 0 and S naught is 0. Only at this condition it will be available. So what we have to do here is when you substitute, this D naught should be substituted as 1, and for this case D1, D2, D3 should be kept as 0. Okay, and when you are going for checking 0, 1, okay, that is D1 data. D1 data alone should be kept as 1. And when you are going for checking D2, D2 data alone should be kept as 1. When you are checking for D3, D3 data alone should be kept as 1. Okay, so this is what is your theory portion. How you have to check. Using Tinkercad, we'll do the experiment and we'll see how you have to check your output. Okay, so now we'll move on, come to the software session, Tinkercad. Okay, from Google, you search for Tinkercad and open and go for circuits. Then now we'll go for creating new circuit. Once your page is open, just to see that you name it Multiplexer. Just then enter, then it will be stored here. Okay, and now what we are going to do here is search for breadboard. That is the basic thing. So we'll just search for breadboard. Okay, so just make a click on the component, and in the work page you just make a click. Now you can see your breadboard is visible now, and after this check whether only one breadboard is there. Now let us take power supply. Type in the component power supply and take your power supply, just make a click and just place it here. Okay, and when you place it, you check whether your voltage is 5 volt. Okay, so now let us connect this power supply 5 volt. You can see in the breadboard you can find this 5 volt, and we are changing the color here. Okay, and obviously you have to ground here. Breadboard ground and power supply ground we are making, and I just for reference I have made it as red for 5 volt and black for ground. Okay, now so let us finish off this breadboard connections. Okay, breadboard interconnections. So 30 and this split. Okay, 30 and 31 I have connected. This is top is ground, so I'm just making it as black. And the second line is supply. Let me interconnect this also. This red. And after that, let me connect the top and bottom so that it will be easy for us when we do the connection. We need not be afraid of connecting whether your supply and ground is available or not. Okay, if you do this, then top also I can use, bottom also I can use. Okay. So top and bottom supply have made interconnections. Okay. Now we require inputs layer. So we'll take switch. So we'll take switch. Search for 6 input switch. So now we have taken 6 input switch. And you know already switches also should be given supply. So I'm connecting this to the supply. Okay. So I just change this to red. From the top, you can see 1, 2, 3, 4. This numbers, no? In that number, you have to connect this. Just make a click. If you make this click, then you can find there will be a table, and so that you can change the color. See, if this connection is not established, then you will not get the cable. Once you click this only, you will get the table. Okay. So I require all the 6 inputs. So I'm connecting power supply for all the 6 inputs. So I'm just connecting 5. Okay. Now after this, we have to search for the IC. Okay. So we said we are going to take first NOT gate. Okay. So let me search for 7404. You can see hex inverter. So this is what is your inverter NOT gate. So I'm just placing this NOT gate here. Okay. So let me complete this first. Okay. Then what all ICs I require, I'll just take and place. I require 7411. So I said that we are going to use 27411. So let me take 27411. Okay. And OR gate, I need one OR gate. So 7432. Okay. So 7432 taken. Let us place. Okay. So already I have said this when you go for placing this, it should be between E and F. Your IC should be placed between this E and F. Okay, you confirm that. Now we'll go for connecting this. How was your circuit diagram? Just to take your circuit diagram. So S1 is connected to first pin of NOT gate. Okay, and S0 is connected to first pin of third pin of NOT gate. Okay, that is your IC. So let us go back here. So first pin, I'm just taking this one as S1. Okay, now I'm just connecting this to first pin of NOT. Okay, we finish. Before we go for this, let us give supply. Okay, so all your 14th pin should be first connected with the supply. So let us connect. See, actually, if the dot is coming 2 or 3, then it means that your connection is not proper. Okay, so you have to get only 2 dots. So where you require the connection, only those 2 terminals, 2 dots alone should be present. If it is not there, just to see that you once again reconnect your circuit. Okay, so this is supply. So all the ICs, let us complete the supply portion. So all 14th pin we are connecting with supply. Okay, now all 7th pin should be ground. Okay, so what we are doing is, this is 7th pin. We have said bottom can be taken as ground. Okay, because we have shorter top and bottom, no, so this negative portion you can take it as ground. So we are just connecting this all 7th pin. I'm just connecting to the ground. So in this marks, let us first connect this one. First, let us connect this AND gate session. Okay, one by one we'll connect the AND gate section. So you can see pin number 13 is connected to D0, and pin number 1 of AND gate is connected to pin number 4 of NOT, and pin number 2 of AND gate is connected to pin number 2 of NOT gate. Okay, so this connection we are going to give. Okay, so you can see pin number 2 is connected to pin number 2 of NOT gate is connected to pin number 2 of AND gate. Pin number 4 of NOT gate is connected to pin number 1 of AND gate, and pin number 13 is connected to D0. Okay, so this is D0. Similarly, so here in this diagram we can see pin number 2 of NOT gate is connected to pin number 2 of AND gate. Pin number 4 of NOT gate is connected to pin number 1 of AND gate, and pin number 13 is connected to the switch, and this is third pin is taken as D0. Okay, similarly we have to connect all other diagrams. So you can see now the second gate, pin number 3 is connected to D1, and pin number 4 of NOT gate is connected to, you can see pin number 4 of NOT gate is connected to pin number 3 of pin number 4 of AND gate is connected to pin number 3 of NOT gate. Okay, so this connection we have to give. Then pin number 5 of AND gate is connected to pin number 2 of the same IC AND gate, or you can connect it to NOT gate. Okay, so let us give this connection. So we'll just short this second pin and fifth pin. Okay. So now you can see pin number 3 is connected to D1. Pin number 3. So this is 3. This is connected to D1. Okay. So I'm connecting this to 4. Fourth pin is connected to 3. Okay. This is D1. Number 4 is connected to this third pin of NOT. Okay. So pin number 4 is connected to third pin of is shorted with the same IC2. So we are shorting this one. Okay. Similarly, we have to complete the rest of the connection. Okay. Now, coming to the OR gate portion. So let us connect OR gates. Here we can see OR gate first pin is connected to 12th pin of AND gate. Okay. And OR gate second pin is connected to the 6th pin of AND gate. And OR gate fourth pin is connected to the second IC of 12th pin of AND gate. And fifth pin of OR gate is connected to the second IC of AND gate's 6th pin. Okay. So this connection we have to do. and you can see this third pin of OR gate is connected to 10th pin, and ninth pin of OR gate is connected to 6th pin, and 8 is the output. Now we are going to connect this connection. Okay, now let us connect this AND and OR. So 12th pin of first IC. So this is your 12th pin. 12th pin is connected to first pin of OR. Okay, so this is OR. So first pin of OR. Then 6th pin of first AND gate. First IC AND gate is connected to second pin of OR. Okay. Next, second IC AND gate, 12th pin, this is 12th pin, connected to 4th pin of OR gate, and 6th pin of second IC AND gate connected to 5th pin of OR gate. Okay, and OR gate third pin and 10th pin should be shorted. This is third pin. Now count 8, 9, 10. So this is 10th pin. Next, 6th pin and the 9th pin should be shorted. OR gate. So 6th pin and 9th pin is shorted, and the 8th pin is your output. Okay. So from gate, as such we cannot connect. So we have to connect it with a resistor. Okay. So just change this. We'll connect a resistor here, and we'll just go for a rotation for connection. So this is what is your rotation. You can see the resistor is rotating. Okay, and we'll just move this here, connect it correct, and after that, for checking the output, let us connect to the LED. Okay, so you just rotate your LED to make proper connection. So here, this the LED should be placed near your resistor. Okay, and you can see anode is connected to the resistor, and the cathode should be grounded. Okay, so you just ground your cathode. Okay, now we completed the connection. Now we'll go for checking the output. Okay. Okay, now we'll check the inputs and outputs. Okay. So already I said selection line is going to be the control inputs. So, and it has to match your data. If data is available and you give the correct control input, then only you will get the output. Otherwise, you will not get the output. Now we'll start simulation. So you can see at the right side of your corner, you can find a start simulation tab. You have to just click that, and you can see if I'm giving S1 0, S0 0, and D1 is 1 means my LED will be glowing. So suppose I'm making a wrong data for 0 0 is my control input, and I'm making a wrong data, that is D1 I'm making on. You can see the control input which I gave and the data which is available is mismatched. So your LED will not glow. So it means that it is a wrong data. So if I want D1, then my control input should be 0 1. Okay. So I'm just changing this. S1 is 0, S0 is 1. You can see the LED is glowing. Next, for the next combination, 1 0, D3 is 1. You can see your LED is glowing. So it is correct. For 1 1, my D3 should be 1. That is 6th pin. Okay. Now we can see you are getting your LED glowing. If I make a wrong combination, okay. So instead of D3, suppose I'm having a data D2 as 1, then you can see your LED will not glow. Okay. So this is what is your thing. And you can see if we are saying this about this switches, the top white is called 1 and the bottom white if you are keeping, that is taken as 0. Okay, this is how you have to check your connections. Okay, and